So yeah, now even officially, welcome everybody. Apologies for the delay, but yeah, sometimes installing on a new machine is a little bit challenging, and yeah, I don't want to go into this now. For today, I thought we should have a look at the topic of background workers and a little bit more JavaScript stuff. We will definitely not do fancy JavaScript framework things like React or whatever, but it's really just plain vanilla to get things up and running. We'll probably go into some more advanced stuff later during the lecture, but not today. Background workers, the main point of the background workers is you have certain tasks that just take up some time, that need some time to be completed, like, for example, creating reporting PDFs and or communicating with other systems that should not take part in that should not happen in the web request. So the web request is blocking normally. So you get the request, and then there's some processing done. And during this processing, on the one hand, the server is busy. This server process is just busy and can't do anything else. And on the other hand, the client is waiting for the response. And yeah, it's just not. It's always desirable to have requests that take less than 200 or 500 milliseconds. And when the things that are actually done in the request take longer, you should always consider moving the stuff back, or some in some kind of background workers. In Ruby or for Rails, there is, well, there are two main things. One, in Rails, there is, since, I don't know, version 5 or so, active job, which is a front end to different other libraries. And there are, then there are a couple of libraries that can be used to do background working. I very much prefer delayed jobs because it's just that simple. And in the system, in the ticket shop that we are running, we currently have, I think, almost 200,000 jobs in the queue that are scheduled to run later because we are doing some clean up stuff. So, for example, whenever we create an order that is paid by, for example, PayPal, we tell the system to check whether everything is fine after a couple of days, just to be totally sure that we don't miss any cancellations or stuff like that. So because of that, yeah, we have like almost 200,000 entries currently. And whenever, for example, an order is created, we create, I don't know, I think it's roughly 10 different jobs that do things like sending the email, creating the ticket PDF, and all this kind of stuff. It all takes place in the background, and we have currently 8 workers that take the jobs from the database and do the task, and they can do this in parallel, of course. Yeah, and this works. The communication level. So to create these jobs, this takes place in the database. So we have a delayed job table that we'll create soonish, and the job description is then written into the database with a timestamp when to run this job, or earliest time to run the job. When all workers are busy, it might be later. And things like error handling and stuff are part of the delayed job frameworks too. And we'll have a look at that. To install it, we just say gem delayed. I think it's delayed job, maybe delayed jobs. I always get that wrong. All right, obviously it was delayed job. Okay, and as always, it may be reasonable to have a brief look into the documentation. That's it. There are different storage backends for delayed jobs, so you could put things into Mongoid. And since we want to store it in the SQL database, we need a delayed job active record because, yeah, this stores the data in active record. So another bundle. Okay. Yep. All right. So now Rails generate delayed job active record. This creates the migration for the database. And the runnable delayed job. So let's have a look at the create delayed jobs table that's created in db migrate create delayed jobs. So you see, this is the way one of these background jobs is described. We have a priority. We have the number of attempts that we already, how often did we try to run this job already? The handler is the actual description of the methods to run. Last error is a column where an error is stored if an error happened during the running of the job. Run at is when to run the job. Logged at and logged by are set whenever one of the background workers actually takes one of the jobs and starts processing. It will be logged by setting these two, and it will be unlocked if it didn't succeed afterwards by setting it to nil again. Failed at if something went wrong, and we can have named queues. We'll probably not use them today. All right. So this is the table we just created. Not bundle. Rails db migrate. All right. Okay, this machine is we didn't run it here so far, so we just Rails db seed. Okay. And let's just look whether there's already a user there. No, isn't. User, you just create one of the command line because it's just faster. Email a@a.a. Name a. And password. As you remember, there is this generated setter for password that takes things through bcrypt and saves them in the password digest. Password is 6 times A. Create at doesn't matter. Verified. Verified. True. TRUE. Yes. Bam. All right. So now we have a proper user, and we could start the server. Which is the directory? Thank you. Okay. Okay, the Webpacker is compiling. This is exactly what didn't work on my machine. Okay, and we have our calculations here. Of course, we don't, for this stupid application, we don't actually need a background worker, but we just consider, well, if we just decide that computing the result of this calculation might take some reasonable time, it would be clever to just store it. So if we have a look at the calculation, oops, this is probably not. There's no escape key here. The heck? What's wrong with this keyboard? So this is the calculation, and for until now we have the result being something that is computed on demand. But let's just consider this being an expensive operation that you just don't want to compute every time you use it, and would take up some time. It would then be reasonable to store the result, to put the result into the database. And for this purpose, we just append a result column to the model and write the result there. And to do so, just stop this. We just generate migration. Add result to calculation. Okay, so now we have a new migration. Change. It's always easier to just copy paste stuff. Add column calculations, and we want to store the result. Well, we just use integer, it doesn't really matter. Okay, so we add a result column. And for now, the result would still be used, the declared methods of the model always take priority over the columns in the database. So what we want to do here is we want to say compute result, and then we say update result. So when we run compute result, the computed result will be put into the result column. Until then, result column is just null. And we could, for the sake of not doing something wrong, you can just say return result if result present, so we don't recompute it. Or we can just return. This function doesn't have a reasonable return value anyway. Okay, so when we reload this page, we first start the server probably. We should run, so there is no result yet. But if we go to the command line and take the first calculation, find one, and say compute result. Then we see this SQL statement, update calculations, set result to 1. And since we are doing integer calculations, this is right. Okay, so when we have a look at another calculation, this one, for example, of course, it's still nil. So when you're dealing with stuff like this, there are mainly two ways to start this computation. First is explicitly after the when you're going to the calculations controller, and after new and update, you could just say, you could just explicitly say calculation.recompute. But it's probably better to use callbacks for this. And in this case, it's an after save is probably the best. Yeah. Compute result. Just uncomment this. So if we do this, after each and every save that is committed on this on the calculation, compute result is called. So we reload the command line. Did that work? Yeah. And now we take calculation number 2. And we just update it in some way. For example, argument 1, 7. Currently, we don't do any background processing. Currently, we are just really doing everything within the same call. Stack level to deep. This is not too surprising because what we do, we say after each and every save, we want to call this compute result method, and update does save. So of course, we're running into an infinite recursion. So there are different ways to deal with it. One would be to have a temporary variable to set. So we could do things like if just computing return, and then say just computing is true, and afterwards say it's false. There are also ways to update models without the callbacks, without running callbacks, but I think this is, well, just sufficiently plain and well to understand. So we just try it again. We find calculation number 2, and we update argument 1 to 77, and it worked. The result should be 110. Yeah, looks fine. All right, so it was computed correctly. Within these after save, there are a couple of these callbacks. There is before validation, after validation, before save, after commit, and the same with create and destroy. So you can for the life of these active record models, there are a lot of callbacks where you can just click in and have your custom code being run there. So this comes very handy in many situations, but you always have to be a little bit careful not to overdo it with the callback stuff, because it makes debugging slightly difficult, and it's just important to have a good trade-off between doing things explicitly and really writing things down and saying, I want this to be done now, and having things done implicitly by callbacks. It's always reasonable to just check whether it's really always right to run these. For example, when you have a callback that informs someone about it, for example, if you have an order, or if you have a callback for orders that informs the customer about things, and you're then not thinking about this callback being in place and doing things, for example, on the command line and tweaking errors that may have happened somewhere, then the customer will be informed for everything you do there. So this is probably not a good idea. So you always have to think whether callbacks are the right tool to use. But for this case, it's just fine. Okay, so when we are doing it like this, then the compute result thing is done directly within the same call. It's really just going down the stack. It's really just called explicitly. But well, we want to use delayed jobs, so we say after save compute result delayed or async or whatever, and we define another method. Well, let's just I'll just show you on the command line what. So if we take our calculation and say compute result, it returns false because this is the last thing that's happening in the method. But if we want this to be done in the background, we can just say c.delay compute result. Then what's happening is, oh, this is nasty. Delay compute result. And then we have an insert into delayed jobs. So in this table that contains the definitions of the things that should be done, we have an insert on the handler, the run at, the create at, and so on. And the handler is YAML encoded code thing. We can just have a look at it because we just take there is just one delayed job. Just clean the screen. Okay, so this is what's written in the database. So the handler is a performable method. And it contains, first of all, the object, which is a calculation that has the attributes ID, argument 1, and so on. All this value before typecast and attribute from database stuff, you can just really just ignore it. And we have and we have this method name thing. So the above stuff really just defines the object, and we have this method name thing. This contains the method that is to be called on the corresponding object, with some arguments if there are. So there aren't any currently, but yeah, so there could be some. I'll just put this into a different pane. So when we take another tab and go to, and there is this jobs work thing. So now we tell Rails to run the actual background worker. Okay, what we see here, the worker was started. The job calculation compute result with ID 1 was running and was completed, and there was one job processed. So obviously the job is pretty easy to finish, so it didn't take any real time, but the calculation was done in the background. So when we are I need to log into. Yes, this password is not secure. I do know that. So, and if I edit this thing here, change this to plus. We remember here, I'll just add some blank lines. And if I save here, I forgot to implement it. Self delay compute result. This is what should happen. This just creates the delay job thing. I forgot that. So obviously nothing happened. This is just fine. Oh, yes. Now we are, in principle, we are just running into the same problem as before, but since we are not in the same function call, but we are creating delayed jobs for all these updates, we don't run it into a Stack Overflow, but we're just getting more and more of these delayed job things. So I just have to stop it here. And we can move this up here. Is that right? No, that doesn't help. That really doesn't help. So one thing we could do here, so update columns is an update version that is not running any callbacks. This is really just doing an explicit update command without callbacks, without validations or anything like that. So we start the worker again. All right, so there was one job processed. This is just fine. So it had to do it one more time, and then it's finished. And now the result should be, yeah, even mathematically correct. Go to times. And as you see, the result is wrong for the moment. It is then being computed in the background. If we reload again, it is right. So this is probably not the behavior actually you'd expect. What we can do there is we can say before save. And by the way, all these callbacks take either a function or a block. So you can also say do, no variable, and the block is being executed in the context of the current object. So we say self.result equals null, nil. Doing too much JavaScript recently. So this is done before the actual saving. So the update will set the result column to null. Hopefully. So let's again take one of these great calculations, change it to something else, save, and we see there is no result so far. But the result was computed in the background, and we can now reload and see it just worked. And this is a situation that you have quite frequently when you're using these background worker stuff. You're doing some update on the models, and you have to wait for something to happen. As I said, rather frequently when you're creating PDFs or for example, if you have a statistics page and say I want to download the data as Excel, creating the Excel table just takes some more time than just rendering plain HTML. So you will you don't want to do that in the web request. So you're then going to a page and say, all right, I have something for you, but be patient and do the thing, the computation in the background, and check whether the data's there already. So this is what we have to do here. I just stop the background worker. And of course, when the background worker is not running, and we're changing something, we can reload as often as we want. We won't get the result, of course, because it's just not being computed so far. And pushing F5 or Command R is probably not what you want to do there. What you want to do there is you want to the page to magically reload or to magically show the correct result when the result is available. So one thing you could do, this is the simplest way to do this, calculation show. Ugh. Yeah, so this is it. So we could go here and say if calculation result. So if we have the result already, we can just show it. Else, yeah, put some kind of spinner here. I don't know whether For Awesome is available, so I don't know whether there's an easy way to add a spinner. All right, so we see that we don't have this thing there. One thing we could do is just completely stupidly add JavaScript and we add just plain function window add set timeout. This gets first command as a function, first parameter. The second is a delay. So and the function is
Spinner border.
Spinner minus border. Ah, lovely. So now obviously something is going on there. Thank you very much, Christoph. Even with correct spacing now. Okay, but still. Window location reload. I think it's a function. Okay, so this just explicitly adds some JavaScript and tells the page to reload itself after 1 second. So let's see whether it works. Okay, and as you might see here in the title bar, the window is being reloaded every second. But this is far from elegant, and especially if the page itself is more complex than this one. This leads to flickering, and if you start scrolling, for example, you may end up at a different position, and this is not the way to do it. It does work, it works, but and of course, if we start the background worker here, it then magically switches to the correct answer, but yeah, this is just not nice. And And of course, the reloading stops because the reloading is triggered only in the there is no result so far branch of this if else here. But still, yeah, as I said, this is really just very, very, very ugly. Okay, and what we could do here is we just take we put calculation result the spinner into a div with a, or probably a span with an ID, so we can reference it from JavaScript. And what we now do is we go we actually use proper JavaScript to do a JSON request and check whether there is a calculation whether the result is available. And just for sake of simplicity, we add data result URL, and this is no, not the category, the computation, calculation path of calculation and JSON. So we just, this is so far nothing has happened. We just changed the markup and we add a span with a data result URL, so that we can reference it from JavaScript. Let's go back, do another change. Yeah, and stop the background worker. Set this to minus, update, merp. And if we look at the spinner, it is wrapped in a data result URL. This is wrapped in a span with a data result URL and an ID calculation result. So we could call this method, this URL or this path, and for now, I guess we won't see anything reasonable. Yeah, so currently there's no implementation for this, but we can add that. So we run into the calculations controller show, and it's now complaining that there is no handler for JSON. It just doesn't know what to do with it. So we go to the calculations controller, go to the show action. And then there's this respond to. Oh, we added this for the index, but we didn't add it for the show so far. Respond to, do format, and format.html render format.json. And now we could just, for example, say render JSON calculation.toJSON. Let's just see whether that works. Okay, so now we have this. We got the same calculation as a JSON object, and we can just have a look whether the result is null or not, and replace the content of this span element here with a result. So we just have to add the required JavaScript. Of course, if you don't want to have all the attributes, you could limit that. In this case, I won't do that, but of course, there may be situations where you say, for example, things like the created add, updated add, or a password digest, or whatever fields may be stuff that you don't want to transfer to send to the client. the toJSON method is very, yeah, it really just takes all attributes and sends them over the wire. It's fine for trying and fine for starting, but it's normally not what you want in productive code. But yeah, so it's not that productive here so far. Okay, so we want to add JavaScript, and we could add the JavaScript over here. You'll probably just do this to quickly set things up, but we will move it to a better place later. So JavaScript. I intentionally don't do the don't put into the else branch to just so that we can set up the JavaScript properly from the beginning. Well, it's not that proper, but yeah. Function check result. So first of all, we have to look whether there is a calculation result span anyway, because for the if the result is there already, we don't do these things. So we say window or document get element by ID calculation result. Wow. Result equals. All right. So if not result, or result span, if not result span, return. So this is the case when we don't, when we already have a proper result, so we don't have to do anything. And okay. And now we're in the situation we found the result span thing. So we say URL equals result span dot dataset. I'm not sure how familiar you are with this DOM manipulation stuff with JavaScript. When things are too fast, please complain. When things are way too slow, please complain too. I really have no idea. I'm even afraid that you might be very inhomogeneous in your knowledge. So I probably do things too detailed way for some. But yeah, if you have the impression it just doesn't fit, please complain. So, and we want to have this result URL value here, and this is we can get it by using the dataset dot result URL value. Oops. And we can just say console log URL to just have a look whether it actually did something. And yeah, for now we just call. Oh, yeah, we just call this function explicitly to see what happens. Okay, so here we are, reloading. Okay, and you see here this calculations.json this is what was output from the from this console log. So we define another function fetch result. No, we define it up here. I think yeah, this should be possible, isn't it? And what this function is supposed to do, it's supposed to window.fetch. This says, I want to get something from the server, URL. And then this returns a promise. And then we have another function. in here, and we jump into the debugger just to have a look at it. Okay, so does not work. You reload here, and nothing happened. Of course, because we didn't call the function. Okay, so now we are. So why don't we see these elements is wrong? Sources is right, isn't it? Okay. Yeah, I thought this. All right. So this is where the debugger stopped. So obviously, there was this window.fetch was already called. So when we look at the server, we see this started get calculations 6.json. This is the call that was made from the JavaScript. And then we run it. Then after the fetch returns, we enter the then case. And in this then case, we get a parameter, and this is this data stuff. Data is a response. This is the response it got from the server. And it was, yeah, obviously, okay, status is 200, status k, blah, 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 blah. URL again. There are some headers. We don't really care about them. And then there should be some kind of body. What we can do, we can just say data.json. Yeah. And we get another promise. So what we do here is we say return data.json, then and another function. Back to the debugger again. Okay. So what we do, we are trying to, or we call the URL to get the JSON. And we get a result, and then we tell that we want to use the JSON body of the result, and this is asynchronously again. So we say we want to have that, and once it is what is being returned here is a promise. So we can say once this promise is resolved, that is, once the runtime system has done this conversion of the response thing to a JSON string or to a JSON object, the next then is being called, and we are going into the debugger again, hopefully. So let's just have a look. We just reload everything. We went to the debugger directly because this JSON returning is done very, very quickly because, yeah, it's just not a lot of things going on there. So when we now have a look at data, we see, all right, this is the object representation of the thing we created on the server side, which is very much what we hope to happen. Okay, and so we can see there is this result here, which is currently null, but it could be something else. So we say data.result. And now there are two cases. One is we got a proper result, and we can put this into this span. The other case is we did not get a proper result, and we have to do the thing again. So if result. So this is the good case. So the background worker did its job already, and we have a result. We have this result span here still. So we can just say result span dot text equals result. The lack of escape key is really, really bad. So otherwise, if we didn't, the result was not computed yet, we have to, call this this fetch result thing again, but probably not. So doing it like this would really be quite stressful for the server. We can just see what happens. So if we now reload, we see the server is pretty busy now, because it is always directly, when one request is finished, the next is being started. But this is not what you want, because it will DDoS your own system. But what we want to do here, the load is going up, the machine is turning hot. No good idea. So what we can do here is we can say window.set timeout fetch result, and do this after 2 seconds, for example. Oh, this is 20 seconds. This is 2 seconds. Okay, so let's just reload. No, go here. And now we see, just clear the screen, and another 2 seconds, and another 2 seconds, and another 2 seconds. And we're polling for the results to being computed. This is this polling is considered somewhat uncool, but it's probably the easiest and the cheapest way to do things like this, because it doesn't really matter. You don't really have to, in most cases you don't have to be instantaneously. So if it doesn't really matter whether the result of the computation is being shown directly after it was computed, or a second later, or 2 seconds later, or 5 seconds later. One thing that may be reasonable to prevent you from DDoSing yourself is to check how long the request took, and take some multiple of this and add it to your 2 seconds, so that if the requests are getting slow because of a lot of traffic, for example, you're asking less frequently. This is something I do every now and then, especially for things that are really user facing. Okay, so this is then reloading every 2 seconds, and okay, so now we start the background worker again, and then after some time, hopefully the correct result shows up. It doesn't look like. I may have done something wrong. Data result. All right, so it doesn't work yet. So we just put a debugger here. Oh yes, of course. In the meantime, when doing a direct reload, the result is being shown immediately, so there's nothing going on there. So I have to change it again to restart the computation, and run the debugger. Why isn't it showing me? This is something I don't get. So why don't we see the debugger? We have this information debugger paused, but we just don't see it. Don't understand this. Preprint.
longer stop.
Yeah, but it should still show. It's maybe because we're doing everything directly during the rendering process. So. All right, so this time, oh yes, of course. Let's go back here, change the operand again, update map 1, 2.
The problem is somewhere in the Chrome browser.
Yeah, but I think, well, we do use this browser quite a lot. Yeah, let's try again. Let's just change the value again. So we don't see anything. This is what annoys me so much, because well, there is, as you see, it's trying to get the the calculation value. So it is or not, just not running.
Oh, there's the stuff that's debugger.
Yeah, but no, it didn't, because the Windows had timeout check result. 2000 is 2 seconds. So I don't know whether. Right, so now at least we're in the debugger. Okay, we're in the debugger again. This is fine in principle, but for some reason we don't see any code. This is very, very awkward. Well, okay, so we have to do things differently. Yes. So we just good old console debugging. Result span, there are no typos, are there? So there's the debuggers left. Ah, that's the problem. That's what I wanted to do. It's still not entering there. Where is this? So you do have save on focus loss, haven't you?
Maybe you have to put the JavaScript in the proper JavaScript.
Well, normally it should be fine to do it like this. Of course, it's not nice, but it's. I just wanted to do it like this. To do it like this because it's easier to understand. So what we could do, we can say document. And we want to subscribe to the add event listener. And I always have to look it up. It's DOM loaded or DOM content loaded. Check results. Okay, so this should now call this check result thing once the loading of the page is finished. But I still don't get calculation result, not result span, return, console log URL, function fetch result. So this is, I think we have some problem with indentation. All right, so the problem is we just forgot to actually fetch the result. I moved the line up instead of copying it. I apologize. So null, try again, null, try again, null, try again. I still don't get why we don't see the code, but yeah. So if we start the worker again, the background worker. All right, so now we have -25 and we call the done thing is called, but it just didn't work. So probably setting the text is just not the right way to do. Change span content. Maybe inner HTML or something like this. Yeah, it's inner HTML. All right. Not text. All right. Okay, so if we reload here, it's just fine, of course. So, bam. So luckily, this is done now. And of course, the background working or the polling for the correct result stops because there is no other set timeout thing going on here. So do you understand what the semantics of this Windows set timeout stuff is, or have you seen things like this, or? So in the browser just that calls this function after 2000 milliseconds. So what we do is first we tell the browser once the content of the DOM is loaded. So the browser sends a lot of events during or for everything. When you click, when you move the mouse, if you're pushing a button, and all this kind of stuff, there are events being triggered, and you can subscribe to these events. And one of the events the browser sends is DOM content loaded, which is triggered when the browser is done rendering the page. So it has all the stuff is being set up, and the rendering of the page is done. Then DOM content loaded is being called. And this is then when the content is there, the check result function is being called for the first time. Then we check whether or not there is a calculation result there is an element with the ID calculation result, which is available only when the calculation result wasn't present at loading time. This is the HTML being rendered. So if this thing is there, so if it isn't, we just do nothing. There is no result checking required anyway. Otherwise, we extract the URL where we can get the proper result from this data attribute. In HTML, you can't or you shouldn't just add random attributes to your nodes, but you may add as many data whatever attributes as you like. So these are a special kind of attributes. So whenever you prefix something with data minus, you can just give whatever name you want, and this is it doesn't have a defined semantics. So for example, the href of an anchor node is the link target, but for all these data attributes, they have no intrinsic meaning. They are really just, you can just store stuff there. And we could, instead of result URL, we could call it whatever we like. It's really just a way to store additional data on your nodes, on your HTML nodes. But of course, it's reasonable to call them in a way that you can memorize and probably even read for somebody else. So this data result URL attribute is really just there to have a place to call. You could, of course, in this very case, just quickly stop the background processing again, and again change this. And as you see, we have this data result URL. This is mainly the same URL as the current page. So we have this 6.json and we have 6 here. So we could construct it by taking the current URL and trying to find whether there are some parameters that we have to ignore and add the JSON. But this is really just not convenient. It's always reasonable to, as explicitly as possible, add the URLs you want to deal with. Because otherwise, for example, adding a useless slash at the end would lead to things getting awkward, because if you just add a .json here, it won't work, and it's really just reasonable to have all your targets explicitly. All right, and then we defined this fetch result function in here, and this uses the fetch the fetch function of JavaScript, which is, well, kind of modern Ajax stuff. In the old times, you had to use these HTTP, XM, whatever freaky stuff things. This fetch is much more convenient. And fetch returns a promise. So you have to use, so you don't have a say, proper return value there. So what you get is just this is just the browser promises you that it will do things with this. And .then just says, when these things have happened, do the next. And this is what we do here. We take the data we got, or, well, this should be called a response. So we got some kind of response object, or we got the special kind of response object, and we ask this response object to give the JSON body. This is again a promise, and when this promise is resolved, that is when the computation of the JSON thing is done, the next then block is being called, and we have this, and then data is the actual data we got into in the JSON response. Yeah, and then we just get the result out of it and set the HTML, the inner HTML of this span to the value provided. Yeah, one possibility is to do it like this. Then there will just be a space in front of the span. It does annoy me too. But of course, we could also add do things like space plus result here or something. But this is really awkward or really ugly. Okay, so but what you don't want and what you're not supposed to do is write JavaScript right into your HTML files. This is really not the way things are done in well 2000 whatever. So we just remove everything here. I hopefully copied it. And go to the app front-end packs. And here we have this application.js. And we add a new folder. We call it calculate. And we add a new file. We call it index.js. We put everything here. And then in this application.js, we just say import calculate. What is this stupid name? Next time I call things foo again. Okay, so let's see. This should do the trick. Yeah, reloading takes some time because now everything has to be compiled and it cannot find the module calculate. Too bad. Calculate. Yeah, all right. Thank you. So hopefully works now. No. Application. Kaboom. And everything's working fine again. I don't think that doing really proper JavaScript stuff is in the very focus of this lecture, but I still want to do things slightly more modern than this because this is really just as plain as possible. Luckily, inside these oh yeah, no, this doesn't work. Renamed the directory so it can't save. Inside the packs, you can use modern JavaScript, so you don't have to stick to the JavaScript that's actually supported by the browser itself, but you can use more modern syntactic stuff. That is ECMAScript 6, 7, whatever is current hot shit. So what I suggest is first of all, really just let the worker do its job, so we stop stupid polling. What I suggest is really using proper classes and stuff like that. So we just say class calculate again. And again, I do not know how familiar you are with JavaScript, and ECMAScript and whatever. So it may be boring for some of you, but hopefully it's interesting for others. So yeah, we're producing a proper class here. We need to have a constructor. Although what we're doing here is not really worth it, but yeah, we still do it. And we have some static initialize. This is constructor is a language constructor, and whereas initialize is really just a static function that I invented. So what we do is within this initialize, we check whether we have to do some calculations, and if we have to do some calculations, we just start. We say new calculate of result span. Bam. So we then go into the constructor, and we get the result span parameter. We store it. We store it to a, well, kind of instance variable. This is result span equals result span. And we could, for example, say we store the URL the same way. As I said, of course, this isn't really worth it because the problem is so simple. But I very much prefer doing things right, because generally things tend to be tend to escalate later. We may be adding this and that, and so it's just reasonable to do things the right way from the very beginning. So we extracting the URL. Well, we could even log it again. And then we have these two functions, fetch result, or we have this one function, fetch result. And we take it. And we make this an instance, an instance function of the calculate class. So window is something really, something really global. So window is always available. So we can say window.fetch fetch. Well, URL is something that we have to say this.url because we have to specify what URL. And this just says, I want to use the one above here. And result, console. Okay, and result span, we have to say this.result span equals result. And Windows set timeout fetch result. It's fine again, although we have to say this. As those that have some experience with JavaScript, the meaning of this may change within, especially within callbacks. You may be unsure what is the actual value of this in the moment. So for this, therefore, it's reasonable to say let. This is not available in plain JavaScript, but in ECMAScript. Let self equals this. So we just have a local variable, and the scoping of the local variable is totally clear. There is no strange things going on with them. So we can say self here, and everything is safe. And since we are using ECMAScript here, we can use arrow functions. So arrow functions may or may not have a proper body, so with braces around. So if you have these multi-command functions on the right-hand side, you have to add a return. If there is really just one expression on the right-hand side, it will implicitly be returned. All right, and here we say we want to take data and do things with it. We are not returning anything here, so it doesn't matter. Okay, data result, blah, 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 blah. Okay, and we can remove this. And then I want to, oh, yeah. First, we just say we want to calculate initialize. So this is the function that is to be called. Therefore, there must not be any parenthesis because that would be the call itself. So we want we still add the event listener, and we call calculate. This is this class dot initialize, and this should then spawn all everything that's required. So let's see whether it works. So we have to. Yeah, again, no, looks like something went wrong. Calculate not defined. So yes, let's add an L here. It's really tough luck. Okay. So we edit minus update. And let's see. So at least this one was done. Okay. And again, we forgot to set the timeout and to actually call the fetch result stuff. So what we do here is we use this and we call the fetch result after 2 seconds. So reload again. And the background worker was running, so we have to stop it again. And change the operand again to something new, so we get to, yeah, okay. Uncaught in promise, unexpected tokens less than. All right. Oh yeah, calculations / undefined. So there was something wrong there. Result URL. This dot URL equals to this. Again, stupid stuff going on with this in JavaScript. To make sure that this is actually the this you expect, we have to explicitly add bind this. Yeah, I really love this language. I don't want to hear anything about TypeScript. Okay. So at first it worked, then it stopped working. Yeah, of course, because in the second time this is broken again. So we have to bind self to be this. All right. There is a reason why the JavaScript, the good parts, is only that thick. Okay, so it seems to work now. We are starting the background worker again. Yeah, we got a result. I don't know whether why scroll. Oh, no, moved it on. All right, we got this 50 and we are done. So this is the way you could do things like that. As I said, it may be reasonable to, for example, yeah, let's just do this. You just say, I told you that I prefer to un-DDoS myself to be sure that you're not calling you're not doing your polling too quickly, so that you don't break your own servers. Therefore, we could just say do things like this. We say that now equals Is it date new or always get it wrong? New date. Yeah. Now is new date. And what we do is we say we store the new date. Oh, oops. All right, and we can then say new date, which is then the new date, which is now, whereas this t is the old date, and we get the number of milliseconds that passed. So we're just remembering what time it was when we started all this stuff. And when we are doing this try again thing, we can say let wait time equals 2. Well, for example, 2000. So 2 seconds plus new date minus now. I should probably call it then. Well, yeah, anyway. So what we do is we increase the waiting time by the time the actual polling request took. And for example, at 10 times for Switch or so. So just to be sure, we don't call it too often. Console log of wait time. So we can see. Oh, yeah. Again, we just stop the worker. Oh, yes. Great idea. Thank you very much. Wait time was it? Yeah. Thanks. Okay, so again, we change it to something else. Update the calculation. Yeah, and as you see now, the request took something like 15 milliseconds, and we are waiting 10 times the time the request took. So if the request is getting slower for some reason, so we just, for example, adding a sleep 100 milliseconds here. Then you see the waiting time will increase. Just to, yeah, be graceful with your service. This is really not totally required, but I highly suggest it because it makes things safer. Yeah, the waiting time is going down again. All right. And yeah, to see what, oops, to see what's going on there, we could go to the calculation, and in this compute result, add some sleep random of 1 to 8 or so. So the calculation really takes up some time now, so we can let the background worker run and still see something. Okay, so now this time the calculation took 5 seconds because of the sleeping in there. And if we change it again, we are looking at the spinner, and in the background we are doing some processing. of course, there may be situations where it's reasonable to add some information about how often did we do that. So how often did we poll or implement some kind of progress bar. So the typical thing is to have a progress bar that is just and you're really just adding up, but using logarithmic scale. So you never really reach the end, but things are moving fast in the beginning and are getting slower and slower and slower and slower and slower. This is how many of these progress indicators within the browsers that seem to show you how long the request actually takes are working, because they don't have any a priori knowledge about the actual request time. So they're really just showing something, and this something is then typically a progress bar that is, well, it's getting slower and slower and slower and slower and slower. So it will never touch the end, but at some point, it is the result is there. It will then change, and you have the impression that this progress bar meant something, although it's really just for you to being just for entertainment to be true. All right. So I think this is mainly what I wanted to show you today. Just some words. This delay. So I suggest having a look at the documentation of delayed jobs. We should probably put the link into the blog. You can add a lot of stuff here. You can say things like delay run at 3 minutes from now, for example, or give a concrete time. Really, just put a time thing there. You could add priority. You could add different. You can have different queues, and so you can have different workers. So you have, say, 10 workers, but only 2 of them are responsible for the one queue, and the others are responsible for another, or for the non-explicitly queued thing, and stuff like that. So you can tweak this quite a lot. What I like about this this stupid delay thing is it is very easy to add. You can really just put a delay somewhere, and you have background processing. This is really magic. There are other ways to do things. That is, you have some job class that implements a call function, and that is parameterized in some certain way, and use these for the jobs. But I really like this delay thing. You should also have, if you're interested, have a look at the active job thing that is part of Rails. This is more, well, it's considered to be the standard stuff, but I like delay jobs more. Yeah, and I don't think we have to go into this delay jobs and into the details here, because you can just look them up. Yeah, so this is mainly it. Oh no, and one more thing. What you can't do, of course, you can't call another function here. You can't compute result and then do things here, because this delay, of course, changes so no, this what comes back from this line is not what comes back from compute result, but what comes back from this line is a delayed job whatever thing. So you can't change things here, because at this point you don't have the result of the compute result function, but you have the delayed job object, which is, well, somewhat similar to the promise stuff in the JavaScript world. So it's something that will.
do something with the active.
Of course, yes, yeah, okay. Yeah, you can of course say job equals whoop, and then you have this active job, this delayed job object, and you can tweak it in some way. But what's important to realize is that you can't just, if you have something where you have some chained methods, you can't just put a delayed somewhere in the beginning, then everything will break. Although you realize that when you try. Okay, so now I guess that's really what I wanted to say. Yes, Sean. Yes, that is will be a topic of another lecture. So they are there. So this is action cable, if you're interested. So web sockets are there. We can use them, but for today I wanted to do it the old school way and keep WebSockets for something for later. Any more questions? All right. So then this is it. Do you want to say anything?
On the homework, we have to short discussion about.
Yeah, yes. The homework will be in the blog.
There's form in the exercises section in the blog. Please fill in your details there, because I'm confused about the GitHub usernames. I have most of your real names to the GitHub usernames, but not all of you. So please fill in this form. Yeah, that's it from me for today. So have a nice week, and
See you then.
see you then.